The James River is a tributary of the Chesapeake Bay, which means that the way we care for the water here in Central Virginia can potentially affect the quality of the bay. One major safeguard for the river's quality is the Lynchburg Regional Wastewater Plant. This 27-acre facility near the bank of the James receives wastewater from thousands of households, businesses, and street drains around the city of Lynchburg and from parts of Bedford, Amherst, and Campbell counties. This water is eventually released into the river, but only after it has passed through a thorough treatment process here at the plant. On a typical day, the plant handles about 10 to 13 million gallons, but during heavy rainfall, it can process as much as 60 million gallons for an extended period of time. Water enters the facility through several large underground pipes. The line from the city of Lynchburg passes just below these grates, where the combined wastewater enters the Headworks building. The Headworks building is where the first stages of the treatment process take place. Step 1 is mechanical screening. Since the water flowing into the building is coming from both residences and street drains, it often contains objects such as sticks, rags, and plastic bottles that must be trapped by a screening system. Wastewater enters through a deep influent channel and passes through screens which have bars spaced about a half-inch apart. As trash collects on the bars of the mechanical screens, these traveling rake arms automatically lower and rake the collected material up to the top of the screen, where it is dumped onto this conveyor. The conveyor carries the material into an adjacent room and dumps it into a large canister, which is eventually hauled to a landfill for disposal. As the wastewater goes through the screens, it is pumped by these pumps onto the second stage of treatment in the Headworks building, which is grit removal. Just below this concrete deck are a series of grit chambers, designed to remove hard, abrasive materials such as eggshells from households or sand and gravel from roadways that can damage pumps and other equipment throughout the plant. Collected grit is pumped by these grit pumps to the grit classifier room. In this room, grit is pulled up through a screw conveyor to a chute and dropped into a canister for disposal at the landfill. There are also 2 manually operated screens. This one, outside the Headworks building, offers a glimpse of what the bar screens look like, but they are only used during periods of particularly heavy flow. If the manual bar screens are placed into service, they must be manually raked with the collected material either carried to and dumped onto the conveyor belt or placed in a separate container. Once the large debris and grit have been removed, the incoming water can now proceed on to primary treatment for the removal of smaller particles. This process gets underway in 2 large basins called primary clarifiers. Wastewater leaving the Headworks building flows through this long pipe and into the primary clarifier basins. The primary clarifiers remove a significant amount of heavier solids and floating solids, and also begin removing some of the particles that are suspended in the water. Here's one of the primary clarifiers that has been drained for routine maintenance, allowing a clear view of the bottom mechanism. Angled blades along the base of the lower cleaning arm sweep sediment toward a pit in the center of the basin. The pit is intermittently pumped, based on a thickening process, and the collected solids are pumped to a sludge holding tank for processing. Skimmers on the upper arm of the primary clarifier skim the surface of the wastewater, collecting the floating material and dumping it into a scum trough on the outer edge of the clarifier. This material is pumped into a sludge holding tank that receives solids from the center of the basins. In the primary treatment process, about 60% of the suspended solids are removed. Then the wastewater overflows through the weirs into the launder and is discharged through a drop inlet. A pipe from the drop inlet carries the wastewater to a junction box, and from there directs the water under the Concord Turnpike to the first stage of the secondary treatment process, the aeration basins. Each aeration basin is a serpentine channel in which organic materials in the water are biologically reduced. This is accomplished by bacteria and other microorganisms that break down and utilize the organic material. The process also serves to reduce the presence of nutrients in the water, such as nitrogen and phosphorus, which would otherwise contribute to water pollution. The water in the basins is aerated by these powerful blowers. The blowers generate a flow of air that is carried out of the blower building and into the adjacent aeration basin diffusers through this network of pipes. Here is a view of an empty basin with the diffusers on the bottom. The bottoms of the two basins are covered with a network of about 18,000 diffuser heads. Some of these heads are made of ceramic, while others, like this example, are rubber. Airflow to the diffuser heads in the various sections of the basin can be controlled by a series of valves. This enables the aeration basins to maintain the optimal mixture that provides the best breakdown of organic matter in the wastewater. The activity in the aeration basin is referred to as an activated sludge process, and one result of this operation is that the solids in the water begin to develop into larger clusters of sludge that can be more readily removed. The wastewater exits the back of each aeration basin and goes to the next stage of the secondary process, the secondary clarifiers. The 4 secondary clarifiers are fed by a splitter box that routes incoming flow into the individual basins. In these clarifiers, the particles formed in the aeration basin are removed from the wastewater by settling. Most of the remaining organic material is removed using a method similar to the process seen in the primary clarifiers. Here is an empty secondary clarifier that allows for a clear view of the bottom mechanism. As solids settle, a series of collection ports on rotating arms gather the settled sludge toward a pit in the center of the clarifier. Then most of these solids are pumped back to the head of the aeration basin, so organisms can be reintroduced into the activated sludge process. Wasted sludge is typically sent back to the headworks. Brushes at the end of the rotating arm remove algae from the overflow weirs and the launder base. Wastewater leaving the secondary clarifiers travels through a collection vault, where sodium hypochlorite is added for disinfection. The wastewater travels back underneath the Concord Turnpike to a splitter box that routes incoming flow to the individual chlorine contact tanks. Just like in a swimming pool, the chlorine acts as a disinfectant to destroy dangerous bacteria. Chlorine, however, can be harmful to aquatic life, so after being in the contact tanks for a minimum of 30 minutes, the wastewater goes on to de-chlorination. The de-chlorination process includes injections of sodium bisulfite from these tanks to remove the chlorine. The entire treatment process, which has taken about 10 to 14 hours under average conditions, concludes here. At this junction, the treated wastewater is sent to the James River through a pipe that runs under the railroad tracks to a discharge point on the nearby riverbank. Solid materials collected throughout the primary and secondary treatment operation must be carefully processed and disposed of. The solids collected from the bottom of the primary clarifiers and scum that is skimmed from their surfaces are all pumped to a central sludge holding tank. As previously mentioned, a large portion of the solids collected from the secondary clarifiers is pumped back to the head of the aeration basins, where the microorganisms can continue the work of the biological breakdown process. Wasted solids are typically pumped back to the headworks. Under certain conditions, this building is used for the sludge treatment process. This is the gravity belt thickener building. Inside are 2 gravity belt thickeners. Wasted solids from the secondary clarifiers are pumped onto these porous belts that allow excess water to pass through and into a drain in the floor below. The excess water is returned to the headworks of the plant, where it goes back through the entire treatment process again. Thickened sludge remaining on the belt, consisting of about 3 to 3.5% solids, falls into a hopper where it is sent to the sludge holding tank. This is the solids handling and centrifuge building, which houses the main processes for dealing with the solids generated by the treatment plant. Material flows from the top down through its 3 stories, and by the time the sludge has passed through the building's 2 treatment processes, it has become dry and compact enough to load onto trucks for disposal. Solids from the sludge holding tank are pumped to the 3rd floor where the centrifuges are located. The centrifuges spin the solids at high speeds to separate the fluids from the solids. Polymer from the 1st floor is injected into the solids to enhance the dewatering process. The centrifuge takes the sludge to a 30% solids content, and the excess water is returned to the headworks. Thickened solids from the centrifuges then go to the 2nd floor, where lime is added from smaller day bins to stabilize the solids. The lime and solids mixture enters a screw conveyor, where it drops down a chute to the sludge trailers on the 1st floor. The trailers of sludge are hauled to a landfill where the solids are disposed of. The treatment plant must dispose of about 60 to 70 tons of sludge per day. As part of the overall operation, the regional wastewater treatment plant invests nearly $250,000 per year to minimize odors released by the operation. The key to air quality around the facility is the odor control building. Air from odor sources, such as the holding blending tank and the centrifuge and gravity thickener buildings, is captured and diverted to this odor control building. Within the building are storage tanks for sodium hydroxide and sodium hypochlorite, which are used in the scrubbing process. There is a 3-stage wet scrubber system on the roof of the building. Air is pumped through a plastic media bed, where the caustic and sodium hypochlorite are added. This process removes odor-causing pollutants from the air, and the treated air comes out through the air stacks at the end of the process. The control building houses the main control room, the wastewater laboratory, and the supervisory control and data acquisition system. The control room serves as the command center for the treatment plant. From here, operators can constantly review monitors that provide real-time information on processes throughout the plant. Many of the plant's treatment operations can be controlled from this room as well. These operations involve more than 600 pieces of equipment throughout the facility, and the plant's maintenance shop keeps all that hardware running smoothly. When parts need to be repaired or replaced, technicians here have the tools needed to get the job done. Of course, the entire plant exists to protect the region's water quality, and the main laboratory here in the control building helps to ensure that quality. Lab technicians conduct tests every day to check the consistency of the plant's process operations, and also the quality of the final discharged treated wastewater. The treated wastewater must meet specific pollutant limitations, as set forth in the permits issued to the plant. The many operations of the wastewater treatment plant must go on round the clock, every day of the year. But the result of this effort is a cleaner environment from Lynchburg all the way to the Chesapeake Bay.